Jai Hind to all. I'm here to discuss the topic on data analytics because this is a new subject that has come up in data science stream of computer science, that is talking about data analytics and its application, its visualization, and various convergence technologies are involved when we talk about data analytics. So, since it is a third year paper, so there are some prerequisites which we need to know before we dive into this subject, and that is why I have not started my content with the syllabus itself. First, I should fulfill those prerequisites. That includes what all we should know before we dive into the subject, like why we are getting what is the importance of data analytics, why it is becoming so important in these days. Moreover, when we have big data and then we have big data technologies, and there are various sources of data that we are getting. So, how data analytics will play its role in identifying the pattern, or identifying the market needs, or identifying what is the research that is required behind. So, all this is a basically combination of various technologies. Just to start with, I have come up with this content that is talking about Industry 4.0. That includes, these are the various dimensions that one should know before diving into data analytics. Why do we need data analytics, and what are the various sources of data that we are talking about, and what is its importance. So, Internet of Things is already existing, IoT, giving us lot of data for us to analyze and understand some patterns. These are the various components: cyber security, then augmented reality, big data, autonomous robots, then additive manufacturing, simulation, system integration, cloud computing. These are making up a new industry, that is Industry 4.0. So, our focus area in this subject would be around big data and around big data, because that is giving us the source of data. But again, if you talk about unit 2 and 3 in the subject, it will talk about machine learning, and then unit 4 will talk about data streaming, fast flowing data that we get, how to analyze online data, and then finally visualization, because the whole paper is a combination of data analytics and visualization. But since I want to make some prerequisites clear in your mind, that is why I am starting with a very general topic of what is IoT. Basically, I am not going to teach you IoT. I am just giving you an idea of what are the sources of data that we can have. And these are the various sources of data being a major component of Industry 4.0. So, when you want to interact with various devices, IoT is a bliss, because it is basically Internet of Things, wherein all the products are available on your IP addresses, and through that we are getting data from various devices. Good enough. That needs to be analyzed. Basically, we have to relate why has IoT been so important for data analytics. That is, I'm trying to relate. Second is big data. Then where are we getting these data from, and why do we need to analyze all those data? Is various sources of big data. One of is IoT devices that we are getting. Another can be various volume, variety, velocity of data, and then we need to first of all store it, analyze it, and then find certain intelligence from that data. So, big data is playing its role in, it's basically an umbrella term which is playing its role in collecting, analyzing, and storage of large amount of data that we are getting through various internet sources, or maybe various devices, various sensors that we are going to talk about, various V's, velocity, variety, volume of big data, that we'll talk in detail. I'm just giving you an introduction. How are these connected, and why is analytics so important for us in this scenario, and that why has this subject come as a new subject for data science people. Then we have machine learning. Obviously, when we have so huge amount of data, all analysis cannot be done by traditional statistical methods. Then we have certain algorithms evolved from that statistical method, and those are all machine learning algorithms. So, these machine learning algorithms are good at creating the statistical model that has been mentioned over here, and then for future prediction, and based on the past data or big data. So, what I want to emphasize over here, machine learning is basically an evolution from statistical methods of analysis of data. So, machine learning also plays an important role in analyzing Although its basis is in statistics, but it has gone far beyond statistics because of the capability of the machines to compute and because of the environment ecosystem that is given by big data environment, that is able to store this huge amount of data and then apply these algorithms, machine learning algorithms that are basically starting from statistical methods, but they are leading towards much ahead of that. If you see, the basis may be statistical methods, but they have moved much beyond that, taking those concepts. So machine learning has an important role. Why? Because we have huge amount of data that needs to be stored, that needs to be analyzed, that certain pattern has to be identified, and that all includes. So machine learning, broadly speaking, data analytics will contain all this. Machine learning, big data, all this are part of analytics. So machine learning has an important role to play. After that, artificial intelligence now has become, I mean, it is a general term. When we talk about machine learning, it is a subset of artificial intelligence. So these terms we should be comfortable and knowing. It is the prerequisite before we understand before we actually appreciate why do we need data analytics and why do we need so much of prediction or analysis. So what all subjects or what all is the convergence technology that is getting into it? That is my point of discussion over here, and that is why AI is, I mean, no doubt an important role to play in data analytics. Then natural language processing. Basically, if an AI is a umbrella term, then NLP and big data and machine learning are its subsets. So natural language processing in itself, it is basically a part of, if you talk about broadly, it is a part of AI. But in itself, it is a very vast thing that we are going to talk about. Natural language processing should be able to understand the natural language with, I mean, with even if it is, there is a change in pronunciation, there is change in context in which it is being talked about. So there on NLP is altogether a new or in-depth topic, but we should know what NLP is and what is the relation between NLP, machine learning, AI, and how it is going to add to the analytics part. Then of course, deep learning is the new term that is another term that we should know apart from AI, machine learning, then deep learning. Then deep learning, next slide I'll be showing that these are basically part of AI, but again deep learning is wherein I'll tell you the difference. Basically attribute selection has to be done by the algorithm itself, or it has been handpicked by human. That is the point of difference of deep learning, but we'll discuss all this further. I'm just flashing those terms in your mind so that we are able to understand the purpose of data analytics. Because I don't intend to teach deep learning, it's altogether a C in itself. So that is one point of difference we should be able to appreciate between machine learning and deep learning, because these are the algorithms that are going to come in your unit 2 of data analytics subject. So wherein we need to understand that what are we doing when we are handling traditional machine learning algorithms or deep learning algorithms. This let me tell you, unit 2 is altogether about machine learning, and all the algorithms starting from the classical methods to the neural network or deep learning methods are included in your unit 2. But I'm trying to explain this over here just because you should know we have to think in these lines. So traditional machine learning and deep learning, a point of difference one should always know. When we are talking about machine learning, then we are basically, these steps are common, that we are giving an input, there is some feature extraction happening, and then classification. Then this is a classifier that we have designed to classify the image as maybe dog or not dog, or true or false, whatever classification we can have. It is just talking about binary classification. There can be multi-class classification as well. So, here the decision is only to take whether the diagram is of a photo is of a dog or not, but there can be other classifications also, wherein you may give an input and try to identify whether it is a cat, whether it is a dog, whether it is a cow or not. So again, let me focus over here. If you want to classify this through the machines, how do we go about it? We first identify those things based on their features. Features mean their attributes. So these are being done by our algorithm. Classification algorithm is going to identify those attributes and then classify it, right? So what are these features? These are the features. Like if we are, if we have to teach some shape of a new object to a child, we'll have to first explain it, each features. Like suppose we want to teach how to identify a dog, then we'll have to identify, explain those features. Based on those features only the child will be able to differentiate whether it is a cat or a dog. Those features may start from, say, if we want to let it differentiate between a dog and a cow. So first attribute that we can pick up is the height of the animal. Second attribute, whether it is having 4 legs or it is a 2-legged, because if he doesn't identify whether it is an animal or a man, then that can be one feature that can be differentiating between man and an animal. Another feature can be being 4-legged, and then height of the 4 legs, what are the size of the body, if we want to differentiate between cow and dog. Similarly, what is the size of the tail? So these are the features that we talk about. These are the feature extraction. What are features? Features are the attribute through which it is being differentiated among various classes. Here, what are the classes we want to identify it as? Dog or not a dog, or animal or man, human being. So we are trying to make a algorithm or a technique by which algorithms are able to identify it, instead of, like, when we're talking about AI, then we're talking about, bringing the same intelligence of a human into a machine. So how does human understand or classify things? Based on those attributes that I've been talking about. So the same has to be done through algorithm now. And so one of the important step would be feature extraction, means identifying those features based on which it can be differentiated. So as an example I gave for dog and cow, the height of the body, the maybe the tail, length of the tail, these are the differentiating factors. So the machine has to be shown those differentiating factors, those attributes, based on which it is able to classify, and based on which we are basically getting a classifier designed. So this is the basic machine learning algorithm. Any machine learning algorithm will take some input, identify certain important attributes, based on which, if you want to make a classifier. As of now, I'm talking about classification algorithms only, because there is a lot classification, clustering, association rules. There's a lot of things that we have to come in unit 3 and 4. But as of now, I'm just explaining what is traditional machine learning and how it is different from deep learning. So this feature extraction, the attributes which are fed by, if we if we handpick those attributes and feed it into our classifier, if you feed it into an algorithm, then that is the case of traditional machine learning algorithm. And by now we have moved much beyond traditional machine learning algorithm to deep learning algorithm, wherein we want that feature extraction task to be done by the algorithm itself. So when we are handpicking features and feeding it to the classifier, then it is the case of traditional machine learning algorithm. And when we are taking the attributes, just taking the inputs and expecting the feature extraction plus classification work to be done by my algorithm, then it is a case of deep learning. So this point of difference should be clear, because these are we have evolved much beyond machine learning now. We are towards deep learning, neural network, and many other advanced terms now, but we should know at least the basic differences. So we have talked about traditional machine learning, and then deep learning is the same thing. The same explanation is there on this slide. So how are they all connected? Basically, when we see, this is the convergence of technology that we are talking about. How are they all connected? Had I shown you this diagram before explaining all those terms like big data, machine learning, algorithms, data mining, then this would have, you wouldn't have not been able to appreciate it. But I want you to appreciate this fact that when you are doing data analytics, then you are basically playing with data analytics is one part of it. That includes data mining, that includes big data analytics, that includes various softwares behind it, various methods and algorithms behind it, that they can start from, algorithms can start from being very classical statistical methods to advanced machine learning methods that includes your deep learning, neural network, all those things. And this is all the field of data science that we are talking about, and data analytics and data science, data analytics and data science. Data science is a broader term, and data analytics is, I mean, you can see just a part of it. So, but we cannot discuss data analytics leaving behind these terms such as big data, machine learning, and all those things, right? So, we have to play with all this, and this all is there in your different units, right? So, unit 1, 2 is about machine learning, unit 1 is introduction, unit 3 is 3 and 4 is about big data, data analytics, and 5th is about visualization and all. So, we all need to appreciate this point that when we are handling data analytics, we are not solely independently talking about data analytics, but it is in convergence with those technologies such as machine learning, big data, data analytics. They are all in itself as a separate topic in itself, and the convergence is there. Yes, then why do we need, why I have put up this slide, that all this experimentally we are going to handle through Python. Why Python? Because it is an open source software available, and it has got various libraries to support our machine learning algorithms, our data analysis, our playing with the data, everything we are able to do with the Python. So, that is why our practical aspect will be handled with the Python, and theoretical aspect, various units I have already discussed that they are containing machine learning, big data, and various streaming concepts. So, Python, again, there are a rich set of libraries that I would discuss further in detail when we get into our lab sessions. Why do we need TensorFlow, XGBoost, Matplotlib, Seaborn? So, few are all, there are, why we are using Python, the most important thing is it is open source. Second of all, there are rich, it is made up of rich libraries which are available for handling this data analysis, for handling this machine learning algorithms, for handling this visualization aspect of data. That is why I am trying to tell you that we need to dive deep into Python with machine learning. But let me tell you, it's not only the Python which is rich in all these libraries. There are other tools that we have. We have R Studio, and I've got this screenshot to show what is the GUI of an R Studio. Although we will be not working on it, we can work with R Studio, we can work with Veka, or we can work with this Colab for Python. But I just got these screenshots to make you aware that there are other tools also. MATLAB is also there, which is going to support all this analytics aspect. But we are going to work in Python on Colab for all these experiments based on data analytics and machine learning, which is there. So, this is an R Studio GUI wherein although we will not be working on it, but I just want you to make it comfortable. But this is also an open source. If you feel like, you can work on that also. But its syntax are equally simple as in Python, and we can see. So see, there are 4 quadrants in an R Studio. If you download an R Studio, which is freely available, then you will have certain these 4 quadrants, which is, this is the console part, this is where you code, and this is your new connections or libraries that you're going to add, or the data sets that you're going to add. You can set the path over here, and this is the various packages. If you, I'm just taking the screenshot, if you download and explore, there are various packages available at this. So, you can explore on your own for your Studio. Then this is a screenshot I have taken for Python or maybe Colab, just to show how it is. Although we will further dive into it, Colab we will be working on it. So, we need not worry much about it. Then we have why Python is required. It is simple, syntaxes are there. Then it is, it's the company, Google is also using Python. So, if Google is using Python, means it's going to support all big data activities, all data analytics activities. That is why we should go for Python, not R or Veka or MATLAB. This is my recommendation. So, basically advantages of Python, that is interpreted object oriented high level programming. This is okay. We all should know that why do we need Python, or what is the advantages of Python. So these slides are about that only. Then Python, why it has become so popular? Because of the high salary that is available to the people who are working on Python. So why to use Python? These are the most important things. First of all, even web designing aspect can be handled through Python. And tkinter is a great GUI support that is given in Python. Then system programming is also possible, wherein most of the time we think that C is the only language which is going to support system programming. But Python is rich in even at the system level programming, or if you want to go for GUI designing, if you want to go for web development, then you want to handle your database programming, scientific computing, gaming, image processing, and mobile development. I mean, if you take any of these streams as your career plan, then you will have to make yourself comfortable in Python only, because Python is going to support all of them. So at one point of time, you may be a web designer, maybe after 5 years, you may go for your some data scientist role, right? Then you can switch over easily because you are comfortable in Python. So you can switch over your roles when you are with the Python. That is why, because there is system programming support, GUI support, web development support, database programming, everything is there. It is a whole ecosystem that is required for any kind of development, starting from web development to system programming to using those data analytics, using those predictions, all those things. So that is why I recommend that we should go for Python. So, but we should know what if there's C Python, there's Jython, there's Iron Python. These are various variants of Python that is going to be specialized in those libraries. So, who was the founder? No doubt, it's the Guido van Rossum in 1991. He was the one who contributed towards Python. Why I want to focus on it? Because basically future is with Python only. And whether you go for, I've just showed you, whether you go for web application, machine learning, or data science role, or system programmer role, you need to have Python enough. So that was the discussion on that. But now I want to highlight those libraries in Python which you will surely need for your laboratory in data analytics and visualization. The lab which is associated with this. Lab is also new, even the subject is new for you in this semester in third year. So that is why I'm talking so much about prerequisites, and that you all should know before you dive yourself into this subject. So these are the various libraries that we will surely use. There's a hell lot of libraries in Python for various purpose, but these are the ones which we are going to use in our practicals, which we are going to use for our data analytics and visualization purpose. Scrapy is one of the most popular Python data science libraries, which is used for building crawling programs. Means why web crawler? If you want to make a web crawler, we have to know about Scrapy, because it can retrieve data, that can retrieve structured data from the web. So why do we need this structured data from the web? Because this is the most common application for Scrapy would be when we will be handling Scrapy and Beautiful Soup, when we will be handling with sentiment analysis. Now, what is sentiment analysis? Sentiment analysis is an application, broad application of data analytics. I have all those content with me in my future slides, but let me go stepwise. What are the libraries that are important for us in Python? Because we have to relate this to our practicals as well. And those, so Scrapy would be, and Beautiful Soup, these are the important libraries that would be used for web crawling. And why do we need web crawling? Because we need certain code that is able to extract data from our websites, right? And then we are able to analyze it. Maybe we want to analyze some data based on Twitter or some blogs that has been done. So we need these libraries to capture those data, those unstructured and structured data, unstructured data or structured data, whatever is available on my website. And then taking that input, we can go for sentiment analysis, right? So that is, you will surely require these libraries when you are handling sentiment analysis. And sentiment analysis is one of the major application of data analytics, right? And we have a sentiment analysis practical as well in our practical lab, and this content is there in our 5th unit as well. So I'm just trying to connect and give you an overview of your subject. Then data processing and modeling, we need NumPy, we need SciPy. Why do we need NumPy? Because we have to handle those arrays, those vectors, because those attributes that we are going to collect, the value of the attributes that we are going to collect is into all these vectors and all these arrays. Then why do we need SciPy? All scientific calculations, integration, optimization, statistical methods, linear algebra, simple, all scientific calculations can be done through all this NumPy, SciPy. Then pandas. Why do we need pandas? Because it is giving us a, Excel sheet, like it is giving us a benefit of a row column. Like we have data in our Excel sheet, row column elements are there. So that 2-dimensional data is available with us in the form of table in data frames. That is why we need it. Converting data structure to data frame object, handling missing data. So why do we need pandas? Just to be able to convert our data into a tabular form, into a data frames, and then working on it, right? Data, it must have for data wrangling, manipulation and visualization. Why do we need this? Because our data should be there in our data frame, wherein we can treat it, we can clean it and use it as an input for our machine learning algorithms, right? Then we have Keras, which is going to handle Keras, TensorFlow, and all these. All these libraries are going to handle our deep learning methods. Then scikit-learn is for all machine learning algorithms. So you need Keras and scikit-learn for basically machine learning algorithms. And then you have PyTorch. Basically, it is required when you are handling your deep learning algorithms, because deep learning algorithms are highly computational intensive data and computational intensive, and that is why we need to we need to have a better computation with GPU. That GPU acceleration is there. So that is through PyTorch. Maybe we will understand this concept when we are handling our neural networks or deep learning method. Otherwise, we'll be able to appreciate the rest of the machine learning algorithms even without PyTorch. Then we have TensorFlow for the machine and deep learning supports. Then XGBoost for machine learning and all. Matplotlib. Now, data visualization is an important breakdown of your syllabus, wherein we're talking about data analytics and visualization. Although that visualization has come only in your 5th unit, but why do we need it? When we are experimenting and when we are playing with data in a lab, you will see we'll be using data visualization from day one, because we need to understand what the attribute is, what is the mean, what is the variance, what is the health of the data, what is the shape of the data. For all that, we need to know data visualization tips. And that is why Matplotlib and Seaborn are important libraries that we will be using. Matplotlib and Seaborn are the ones which are going us to help us in visualizing the statistical attributes of our data. What is the variance, what is the mean, what is deviation, and is the data normally distributed, or it is skewed, or it is well available in a bell-shaped curve. So all those health of the data, or telling about the data, first view of the data is possible through Matplotlib and Seaborn. And so you have to be very handy with all these two libraries. Then Bokeh, not basically used for JavaScript widgets, maybe for visualization, but not very important from our data analytics point of view. Plotly is another very important data visualization tool that we'll be using very often. And then PyDot for graph and all. It serves as an interface to graph. Not much useful for our data analytics point of view. Plotly is important, Matplotlib is important, and Seaborn is important. So let me just conclude over here. These are the ones which are going to help us for our machine learning algorithms. Machine learning algorithms still Keras, PyTorch, Then Matplotlib is basically for our visualization aspect. Yeah, machine learning and all. Here is the key point that I was discussing. Artificial intelligence is a very, very broad and wide term now. Machine learning is a part of it because we are trying to make the machine learn as and make it intelligent as if human is thinking. And then you have deep learning, good enough, wherein if you want to find the difference between machine learning and deep learning, we have talked about it, that if the attribute selection is done by the machine or the algorithm itself, then it is a case of deep learning, or else if it is done by the human, by its human intervention, by our choices, then it is machine learning, handpicked by our handpicked by our whoever is designing the algorithm, who is working on it, then it is a case of machine learning. But where is data science? Data science is on the convergence of all this. And we are going to talk about data science in convergence to AI, machine learning and deep learning. That is why our syllabus is also very vast and lot of understanding has to get into it. Why are they connected? Why is data science connected? Why is big data connected to machine learning? How it is connected to AI? All this understanding is important for us. Let us move towards timeline that is required to be able to appreciate our industry, starting from 1980s with ERP to CRM, customer relationship management in 90s to 2000 e-commerce websites were there, and then finally big data. And then if we talk about 2022, it is more about machine learning, deep learning and all those applied on those big data. So that is why we have to evolve through these technologies. We have evolved through these technologies and got into big data, data analytics in these days. Again, let me focus on data, big challenges, because big data, big challenges. If we have big data, we have big challenges along with. And that has to be, no doubt, solved with machine learning, with big data ecosystem, Hadoop ecosystem, all those. But let me just tell you what are the data analytics process. Because what are the process that we are taking, we are understanding the business domain, good enough. Then we are collecting data, good enough. Then we are cleaning and curing data, right? So that we are able to feed into our machine learning algorithms. So we have machine learning algorithms playing their role somewhere over here only. While data, when we are understanding the business concepts, domain knowledge and collecting data till that point and curing data, till that point we are talking about data analytics aspect. But when we want to make model, and do certain prediction, certain interpretation, at this point we need machine learning. Then after certain prediction has been done by our algorithms, then modeling and visualization is there, and then how do you interpret that data? How do you interpret that visualization that you have been shown? So this is the whole arena of a data analytics process, where machine learning is just a part of it at this point. So we should have in our mind, data analytics is a much broader term, and machine learning is just one algorithm, few algorithms that we are going to use it for analyzing data. Good enough? After understanding this point, let's move towards what are the various sources of big data that we are getting. You see, I'm toggling between machine learning and big data because they are all connected somewhere or the other with data analytics. That is, I'm trying to connect all those terms. And for that, the prerequisite that we should understand what is machine learning, what is big data, what are various algorithms in machine learning. That is why I'm trying to cover those topics over here. And with the same, now in these slides, I'm focusing on big data aspect. So what are the various sources of data that we are getting? Various Facebook real-time social analytics sources of data, then various sensors, then various Google real-time web analytics system is there, then Google real-time search engines are there. All the search engines, social media websites which are available, various sensors which are throwing data are basically needs to be analyzed. What is this diagram trying to explain? Online transaction processing system. We are going to handle, in fact, we are handling online transaction processing system that is rich with data. We are having a huge source of data, various with high volume data is coming, and we as a we are not able to handle that data totally for analyzing it. So what is happening? We have a big source of data that is coming in. We are not able to handle it to all extent, but to some extent we are going to use that part of the stream to analyze that data. So this girl is able to drink some part of water, but lot of other is being wasted. So it is something like whole system ecosystem of big data is giving us huge data, but we are not able to analyze those all the data, but some real time data, a part of a stream or maybe windows of data we are going to collect and work on it. That is online transaction processing system, and this whole concept will be required when we move in unit 3 and 4, because unit 2 is about machine learning, 1 is about introduction, but 3 and 4 is talking about fast flowing streaming data, real time data that we're talking about. Big data is again, it's here the same diagram has explained. Working with big data is like taking a drink from a horse. Most of the data will run past, just like most of the water does. It will come and go out, but we are able to analyze by focusing on a part of it or not, on that flowing, fast flowing streaming data or not. That is a challenge that we are going to talk about. The goal is to set the right amount of data out of the data stream as it flows past, not to try and drink it all. So obviously we cannot drink and take all data as an input and try to analyze and, but we can do it only for a part of it. Not so that is why what should we focus as a data analyst, that we should take the right amount of data to be able to sufficiently predict or show certain patterns, or maybe do certain prediction, or maybe do certain prescription. The various types of analysis also will be talking about predictive, prescriptive, and prescriptive, predictive, and analytics. We'll be talking about all those, but I'm just talking about what is the challenge with the streaming data. Why streaming data? Again, data analytics cannot be done on a static stale data. If we're doing sentiment analysis on a stale data, then we are actually not doing it, and we are not able to derive any intelligence out of it. If we are able to handle online data, we are able to handle fast, fresh data that is available on internet, then only we are able to recommend certain products, recommend certain, do certain sentiment analysis out of that streaming data that we are getting. That is why all those are required, and to handle that, and to handle that, we should have certain enough bandwidth in terms of how do we store it, how do we analyze it, how do we compute it, right? So the goal is to set the right amount of data out of the data stream as it flows past, not to try and drink it out. By focusing on the important pieces of data, it makes big data easier to handle and keeps effort focused on what is important. When we are going for data analysis, when we are going to for identifying certain prediction, when we are going to do certain recommendation, personalized recommendation, or when we are going to understand the sentiments, then we should be not focusing on entire data, but that part of the data that is able to solve a problem of analysis or maybe prediction or whatever we want to do out of that data. So why should we talk about data analytics? Because you see the growth from 6, 7, 11, 12 till 15, but this trend is showing that there is a great opportunity in big data, data analytics, and machine learning arena. So the same has been brought up over here, where you can see yourself as data scientist, big data, data analysis. These are basically the area where you should focus, so that you are able to capture and you are able to project yourself as a data scientist, or you are able to project yourself as per the requirement of the market. So capturing big data, okay, these are basically roles that you can play. You can be a full stack developer, data architect, data scientist, a Java developer or ETL developer in the beginning. Then you can be data analyst, marketing analyst, data scientist, report writer in your later phase. And then you can be a CTO, project manager or report. Why I'm showing this career growth plan, so that you can actually work in it and see what is the importance of this subject for you. So if we talk about where is big data being used, healthcare is the most, even beyond, more than healthcare, it is technology. That is basically where big data analysis is happening. So if you want, now when we have come into data analytics and data science, then what are the tools that we should know? We should have idea. We should be well versed with Python or R, SPSS or Julia, or these are all basically technology that we should know. Then we should have an idea of MapReduce. If you want to talk about skill set that is required, MapReduce, Spark, MongoDB, then Cassandra, all this is basically NoSQL databases that we should know about. And then we should have an idea of how to handle data through R, MATLAB, any of these, not all. You will not need all of these tools, but combination of few of these tools will help you identify your, will help you in placing yourself well in this field. So either you should know Python or R or all this SPSS, which are basically tools, and then you have big data tools over here for MapReduce, MongoDB. Then you have your other tools for general analysis. So what I recommend Python, because R and Excel is not very good for handling machine learning algorithms, but R to some limit, and this one MATLAB to some limit, and Python to some limit are good in handling machine learning algorithms, and that you will require. I have shown you in that previous diagram where is the role of machine learning. These are various sources of data. Social media websites, then various sensors that are throwing huge amount of data that needs to be analyzed. They can be structured, unstructured, semi-structured data that we'll be talking about. Various velocity, variety, volume of data that we'll be talking about. But I'm just giving an overview or the flavor or the convergence that we are going to talk about throughout. Then we have various data coming through cameras. Then we have various data coming through smartphones. These are various sources of data: Facebook, Twitter, YouTube, Instagram, Pinterest. These are all various sources of structured, unstructured, and semi-structured data that we'll be talking about. Here it is again talking about your Python, and this was a screenshot of Colab to give you an idea what Colab will look like. But we'll be working on it, so we need not worry much on this. But now when we're talking about data analytics, then what are the basic main implication area of data analytics where we are going to use it? One of them is sentiment analysis. It is a common NLP task which involves classifying text or part of text into predefined sentiments. Now, when we're talking about sentiment analysis is one of the major applications of data analytics and recommendation engine and all that we'll be talking about in our upcoming lecture.